Hi there. Let's look at acid-base problems. So we're going to be doing pH, pOH, Kb, Ka, and molarity pH and pKa calculations, right? So the questions you sent me for buffers, salts, and adjustments will be in a different video. So there's not enough time. Okay, so we want to look at what's this pH? pH, that's actually the math formula. Px is minus log x. Normally x is given, you can take the minus log value in your calculator, then you get the px. That's actually the pH, the power of hydrogens, right? So given x, get px. That's what we want to do by using this formula. Px is minus log x. Now you need to know how to reverse it. So that means given px, how to get x. Now px is minus log x times by minus 1, you get minus px, and cancel the minus log x and look at the inverse, which is 10 to the power minus px. That would be x. X is actually h plus, so that means h plus is 10 to the minus ph, and ph is 10 to the minus log of h plus. So those two we want to use in many occasions to interconvert between the pH and the H plus concentration. Now, also it's good to know these two formula. pH is minus log H plus, and the H plus is 10 to the power of minus pH. And pOH is minus log OH minus. The OH minus is 10 to the power of minus pOH. Likewise, pKa, Ka is 10 to the minus pKa, and Kb can be given from 10 to the minus pKa. So the brackets are important in using the calculator. Also, for the water, Kw is 10 to the minus pKw, right? So the last two are not very common, but if you know it, it's easier, right? Now, let's get an example. Yeah, so let's take a weak acid WA problems. So these problems are pH, H plus, molarity, Ka, pKa. So most of it given, one is missing, and that's basically the question. That's the pattern of these questions. But you lay out the ice tables all the same, okay? Now, so let's say I'm given a question, 0.5 molar HCN is given and calculate the at the equilibrium, what's the pH? Right? So the Ka is given 1 times 10 to the minus 9. So we're going to use that one. Now, we can also write here. So let's see. Yeah, we are looking for pH, OH. They both are interconnected by the pH is minus log H plus, right? So HCN is HOH, equilibrium with H3O plus and Cn minus, and AQ, liquid AQ. Now, because its water is liquid, we can write a Rice table for the balance equation, 0.5 molar, and water is liquid. You can cancel it out actually, so it's easier for the math. And H3O plus, also you can think just H plus, right? Now, that way it's easier. Now, initially 0, 0, minus x, 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 0.5 minus x, x, x for the equilibrium. Now, we also can think H plus or H3O plus is a acid, Ka, constant of acidity, you write, that's the reason. So product over reactant, products are H plus and Cn minus divided by HCN reactant, that is x squared over 0.5. So those two just plugged in the x values, right? Now here, this is the assumption, x is negligible, it reaches to 0, only that x, no other x will be negligible, right? So the Ka is x squared over 0.5, right? And the Ka value is given 1 times 10 to the minus 9 and x squared over 0.5. Now, cross multiplication, you get this, and take the root to cancel the x squared, so you get x, which is H plus. So yeah, so H plus is actually H3O plus, which is x, right, at H plus. Now let's get the value, root of this value, 0.5 times 1 times 10 to the minus 9. And let's get that. 2.24 10 to the minus 5 molar. That's the molarity of the protons, H plus. So the pH is the question, minus log H plus. Plug it in, take the minus log value in your calculator, and 4.65, that's the value. So 2 decimals here in the pH values normally. Okay, so key points. There's normally one unknown. You write a Rice table for the balance equation. Look where the Ka should be written, product over reactants, and then plug in the Ka values. Look for the H plus or the molarity, right? That's what you will be doing. Okay. Now, question 2, example 2, let's look at calculate the pH for, let's say, acetic acid, which is ethanoic acid, also called vinegar, and it's CH3COOH. Your book, grade 12 book, has CH2 CH3O2 likewise, and these are the green ones are the proton, acidic protons. Sometimes I call it HA. I like that one, it's so simple. Now Ka value is 1.8 10 to the minus 5 given. Now, so if I write the formula, let's say so the normal way, HCH2 C2H3O2, H2O liquid, H3O plus hydronium, and the anion, right? So I can simplify HA, H plus A minus, so simple in that way. This one too, HA, H plus A minus, it's better, right? Simple. So all the fancy acids, like let's say benzoic acid and methanoic acid and whatever, propanoic acid, all these acids, in my eyes, I see it HA, H plus and A minus, right? So let's leave this on here, so no need to delete. Yeah. Okay, HA, equilibrium H plus and A minus for any weak acid. So write the Rice table, because it should be balanced equation, and we are actually using monoprotic, right? So let's put the question on the paper here. So when 0.2 moles in 200 milliliter dissolved, what's the pH? That's the problem. So we need to calculate the molarity of the initial acid, 0.02 moles divided by 0.2 liter. That will give you 0.10 molar. Let's put it there, 0.1 molar, 0 minus x, xx, 0.1 minus x, 0 plus x, 0 plus x, right? This is negligible by the assumption because it's so small value, and H plus appeared in the equilibrium, it's a Ka. So product over reactants, plug in the x values, x squared over molarity, right? Now Ka, copy the Ka value, and x squared over 0.10, cross multiplication, write it that way, take the root to get rid of the x squared. Now you get the x value, right? So x value is H plus, so that means we can take the minus log of that one. pH is minus log of the H plus, plug it in, voila, you get the pH. So these two questions are straightforward, right? Let's get the pH value here. Okay, 5.74 up to the 2 decimals, standard method, right? Okay. Now, so remember, for any of these questions, write the Rice table, put the Ka for the H plus products, and then plug in and look for the molarity or the pH. Mostly, even Ka can be calculated, right? Depending on what's the missing one. Now, we need to talk about the weak bases. So the best one, the most discussed one, is ammonia. It will join with water, ammonium, and hydroxides. Now water is liquid, right? But you have to be aware of that one. So H plus and OH minus from the water coming actually. So the ammonia is actually can be labeled as BOH, B plus and OH minus. If you're comfortable, go with the red labels, right? And that's for any weak base. Now 0.2 molar given in the question, this question, and Ka given. Let's tricky one. You're talking about the bases, but you're given Ka. little bit more math to do on this, right? So remember, when you write the givens, you got to be aware of that. So ammonia plus water, ammonium plus OH minus, and I can write it simply BOH, B plus and OH minus for any weak base, rise table. And yeah, 0.2, water liquid has no molarity, minus XXX, 0.2 minus X, and assumption is 0 for this X only, and then OH minus in the product gives you Kb, product over reactant. Plug in the products, ammonium plus hydroxides divided by ammonia, reactant, and now plug in the X values, you will get Kb X squared over molarity. Now, so Kb, we don't have it. We have what's given, Ka. So there's two methods. So I'm going to show you the easy one to use the calculator. So if you use the Ka, Kb, Kw, if you're not well equipped with your calculator, you cannot calculate easily. But this one, pKa, pKb, smaller numbers, you can handle it easier. Only one power to handle. Now, so the pKa is actually minus log of the Ka, right? So because you're given the Ka, let's take the pKa, minus log of the Ka, plug in, look for the minus log value, you get this value. It's a simpler number to deal with in a small calculator, okay? Yes, 9.24 is the pKa. Now, we can plug into pKa, pKb is pKw. So that's the pKb, and the, get the pKb out, 14 minus 9.24, right? That's the pKb. Now, pKb can be converted to Kb, right? This should be Kb, yeah. So 10 to the minus pKb. That is Kb value actually 10 to the power of minus 4.76. It should be within the brackets. Yes, 1.72, 10 to the minus 5, it's a molarity. The Kb value, because we had the OH minus in the product side, that's the reason we write it this way. So you plug in X squared over molarity, take the root to get the X, and yes, so you plug in here 0.2 times 1.72, 10 to the minus 5, root of the whole thing, within brackets, inside, your X is 0.0018 molar. But X is not H plus, it's OH minus. So we're going to look pOH minus log OH, plug in the OH, take the minus log, 2 times 73. That's the pOH. Now we can go back and adjust to the pH. What's that one? Is from this formula. pH plus pOH is 14. We know two things and we can find the pOH. Sorry, pH actually. pH is 2.73 plus, yeah, okay. pH is 14 minus that one, 11.26. Yeah, so that's a weak base. Actually, the molarity is higher, so it's much stronger one, but it's still weak base formula works fine. Okay, thank you.